In this video, we're going to be trying to find the average value of a function over a piece of graph. In other words, on an interval. All right. Now, before we begin, I need to go back and state something that is very important. In other videos, I have gone out and I had said the word value really means a y coordinate. Okay. So when I ask you to find the maximum value or the minimum value or the average value, I'm actually looking for a y coordinate. So the average value is going to be the same thing as minimum value, maximum value, right? Because it has the word value, so it says find me the y coordinate. Now, what's the objective? The objective is to actually state what the average value finds. And what is it that it's going to find? Well, I just stated it. It's going to help me find a y coordinate, but that y coordinate has some significance. All right. And then finally, the second thing that you're going to do for me is you're going to be able to find me the average value of an integral from a to b. So let's go ahead and understand what the average value is. Recall from the last exam that the minimum value and maximum value are y coordinates. Keep that in mind when finding the average value. Value meaning the y coordinate. Okay. How do we find the exact area underneath the curve? Well, to find the exact area underneath the curve, I'm going to use the integral. The integral from a to b of f of x dx, and I'm going to use the fundamental theorem of calculus, and it's going to give me f of b minus f of a. Okay. But I'm not really concerned with this part. I'm really concerned with this part right here. This is going to help me find the exact area underneath the curve. Area under curve. Okay. Now, what I want is I'm going to pretend that out there is since this exact area is a numerical value, it's a number, Mr. Quintana, and that number can be a product of two things. All right. So what I can say is I have a rectangle out there, and that rectangle is going to be the base times the height. And the base, I'm going to use this guy right here, a and b. The base is going to be b minus a. So here we go. Ready? Base times height is the area of a rectangle. So now I know the base of that rectangle is going to be b minus a. So that's going to be b minus a. That's my base. And f of x, that's going to be a y coordinate. All right. So that's my y. But that y is really going to be my height. So I'm going to, instead of writing f of x, I'm going to write it as y. So now I can say any area underneath the curve can be written as, using the fundamental theorem of calculus, the integral from a to b of f of x dx, or it can be written as some unknown rectangle that has a base of b minus a and a height of y. Now, if we were to divide both sides by b minus a, so if I take this guy and I divide by b minus a, and I take this guy divided by b minus a, I'm going to end up with y is equal to 1 over b minus a, the integral from a to b of f of x dx. And this is the average value formula. So what does the average value formula really find? It finds us the height of the perfect rectangle who has the exact same area as the area underneath the curve. All right. So somebody's still not gonna be able to understand what I'm saying. So what I did is in my PowerPoint, I have this. Oops. I have this slide here, and I have a little video, so I'm going to click on it and I'm going to press play. So right here I have stated that it's my average value. Okay, so right here on the dotted line is my average value. So what I'm going to do is I'm going to melt this pink part and I'm going to fill it up to make a rectangle. So here we go. So as I fill it up, and I'm going to pause it right there. Oops, I went too far, right? So let me go back and see, hopefully it'll do it again. And I'm going to pause it right there. So right there, Mr. Quintana, I have some kind of a rectangle. And my base is going to be b minus a, and my height is going to be my average value. So let me go back to the OneNote. and I'm going to outline it in green. So here we go. I'm going to go straight down like this. I'm going to go this way, like this, and my lines are horrible because I'm not. Ooh, that was really bad. I'm going to do that. Okay, so this here is going to be a rectangle. All right, and that rectangle has a base of 9 minus 1, which is really 8. So 8 times this height is going to be equal to the area underneath the curve. That's what the average value is. So the average value is the height of the perfect rectangle whose area is identical to the area underneath the curve. Now, let's look at this. As you can find out right here for this picture from 0 to 1, the average value is going to be right there. So if I was to take this piece up here, this piece, I would be able to fill it up in here. So I'm going to have this rectangle right there. So that piece and that piece, they're going to add up and it's going to create this orange rectangle. And the average value is going to be there. So that's my average value. And in this case, the average value is going to be above the x-axis, so it's positive. Now, what about this case? In this scenario, this integral is going to be negative, and this integral is going to be positive. So in the other video, what did I say about when one is above and one is below? And I do an integral. When I do one above and one below, they're actually going to cancel each other out. So my average value in this case is going to be this line. And that line right there is going to be 0. And this is a very hard one to understand because some of you are going to say, hey, wait a minute, sir. I'm going to take this area here, and I'm going to take this area, and I'm going to create a rectangle like this. And I'm going to say, no. You got to understand that in calculus, this right here, remember, I'm using the fundamental theorem of calculus, this guy can be negative. So if it can be negative, that means it's below the x-axis. And in this case, this guy is below the x-axis, so this integral and this integral are going to cancel each other out. So my average value will be 0. In this scenario here, right here is going to be my average value. So let me draw a rectangle, and this right here is my rectangle. So that means that if I was to take this piece right here, if I take this little piece here, and I melt it, it would fill up this piece right here. Okay. So that would create this rectangle. All right. So the average value here is negative. So the average value could be positive, it could be negative, or it could be 0. Okay. So how do you set these up? Well, it's very simple. If I use the formula, I'm just going to say 1 over b minus a. So I'm going to write down the formula b minus a, the integral from a to b of f of x dx. That's it. So when I do it, I'm going to have 1 over 3 minus 0, the integral from 0 to 3 of my function, which is going to be 3x squared minus 1 dx. And I'm not gonna integrate this. All right. So let me go ahead and set up the next one. Find me the average value of this function here. So I'm going to say it's going to be 1 over 2 minus 0, the integral from 0 to 2 of negative x squared over 2 dx. And you do the antiderivative. You want me to do one? I'll do one. I'll do this simple one, right? So the antiderivative of this, so out here I'm going to get 1/2. The antiderivative of x squared is going to be x cubed over 3, but there's a 2 down at the bottom, so it's going to be 6 from 0 to 2. So I'm going to have 1/2. I plug in the 2, so I'm going to get negative 8 over 6 minus negative 0 over 6. The fundamental theorem of calculus says you plug in the 2 first, and then the 0 and subtract them. Okay, so this is going to give me 0. So I'm really going to have 1/2 of 8/6, and it's going to give me negative 4 over 6, which is negative 2/3. So it's supposed to be negative 0.666. And I'm hoping that that guy is negative 0.666. Okay. And that's it. That concludes the video on the average value.